An overview of all the APIs for MIDP2. So for example, whatever you want, if you get a phone, it says it supports MIDP2. You know, all these functionalities here are meant to be supported. Yeah. Right. So for example, yeah. So this is online. It's an online document. You can just Google for it and you'll find it. So with this is MIDP2, and sometimes what happens is sometimes there could be optional, they're called optional packages that come up. So you have MIDP2, and then let's say a new feature comes in, like location-based services or something for a phone. When those come out, then they also try to create some sort of specification that covers that new feature. So those they usually call them optional packages, yeah. And from here this is NetBeans, you can just see there's a list over here. You can see this list: advanced media supplements, file connection, J2ME. So these are optional. They're not really part of the standard, but they're optional. They just come in. Optional specifications. And see location-based services. So when this is done, then you have the mobile manufacturers and those guys, they now do the implementation to run on their specific phones. So what I'm going to talk about, I'm going to talk about one specific area, though there are quite a number of small things that come up, but one specific area just to illustrate how, okay, you have the specification that says, the J2ME specification that says something, but then when it comes to the implementation, you can have different behaviors. So I'm going to talk about RMS. RMS is a way for the specification for J2ME to store items locally on the device. So it's like a local storage. Let me just go here to the specification and just pull it out. RMS. So RMS is a way to store data locally on the device in some sort of a database like structure. I would like to open it up and just show it to you guys. Let me get this wireless. Let me get a LAN cable so that I can be able to open it up. So you can see this is what it is. It's a package that allows, it's a mechanism for midlets to, midlet is just a J2ME program to persistently store data and later retrieve it. So fine, like for someone who has just gotten into J2ME, thinks that, okay, this is a really simple way to just, you store data, retrieve it, works like an ordinary database. but the real issues behind it do not really come out here. So I just wanted to just use this as an example, and let me read for you something, for example, that comes from the Motorola documentation, right? So with some Motorola phones, what happens is, if you open the storage, you remove the battery, you can lose all the data in the phone. You know, so that's sort of a flaw or an issue, right? Because if it's persistent data that is stored on the phone, doesn't matter even if you remove the battery, it should still stay there. So that's one of the issues that come around. If you're running an application, you remove the battery on some of these Motorola phones, then all the data that was contained goes away. And then if, for example, people download your app and then they want to upgrade, you provide an upgrade for it. So someone automatically just goes and says, okay, download upgrade. On a number of phones, what will happen is the user might not be asked whether they need to keep the data, which already is on the phone. So the new app will be installed, the old app will be removed, the new app will be put in, but the old data will be gone. So you can imagine if your app really depends on keeping, you know, if it's data which is always someone is always keying in data on your phone, and then you do an upgrade, you can find that all the previous data has gone away, so the person is left wondering what has happened to their data. So some of the workarounds to that is that, they're not such good workarounds, but one of the most popular one is to build like to back up the data online. Like you can't depend on the phone. So if like you're building this app and your app is you're expecting your app to be used widely on a high number of phones, then very likely you'll just have to have an online database where you synchronize the data. You know, which is not such a, you know, just building that by itself is a task. But then it's necessary if at least you want to keep that consistency in your app, so that people don't lose data in case of an update, for example. And then this kind of behavior, it's different on different phones. And then, you know, considering all the number of just the manufacturers that exist, even within a particular manufacturer of phones, you'll get different behaviors in the different phones. So you're faced with an issue like, you know, with an issue like this, you find that the manufacturer could have implemented it right on a particular phone. Even, let's say you take, for example, a particular range of phones which have come out from a particular manufacturer. Even within those phones, you can find different behaviors of this kind of the same feature, right? Okay, so let me jump from there. Let me go to another issue on one of the ugly sides of J2ME development. I don't know if some of you have built apps and then you realize that you try to install it and on a particular device, but the memory size is just too small. So one of the issues is that you have, so basically on the phone you have heap size and you have the jar size, which have limitations, right? So if you take, I want to show you an example. All right, so this is from Nokia. All right, so for example, of that list, you can see at the bottom you have maximum jar size, you have maximum heap size. Okay, at least this is at 1 megabyte, heap size is 2 MB. So you have, and that kind of information can vary greatly on different phones, right? So usually what happens is, what has come up in J2ME, you have libraries like LWUIT, so it's called LUIT. I think it's really popular. What it just does is it tries to create a wrapper around the way, how to use the J2ME interface. So you have that library, there's another one called J2ME Polish, which comes with another set of libraries, networking, user interface. So, but then you find that the more libraries you include in your application, the more the size grows. So, and then there's also your code, which has its own size. So, so then it becomes quite a task, because you have to think of the jar size, the size of the jar that can be put on the device. And then you have to consider for the heap size, it becomes an issue when you are allocating memory on the device. So you're not so free to create very large arrays and stuff like that in your application. Another issue is when it comes to I showed you these optional libraries, right? These are most of the libraries here are the cool stuff that's coming out, like location-based services and maybe 3D rendering, stuff like that. But then, for example, let's say we have this location-based service. If you want to support a high range of phones, and maybe you have some phones which don't have location service in it, and then you'd like, for example, a different mechanism, to fall back on a different mechanism to determine someone's location, then you're stuck with having to build two different application versions, two different builds. So for example, so what you'll end up having is a multiple number of builds. And then what usually happens with that now is that it becomes very difficult to maintain the entire project, right? Because you have, for example, this 1 year you have location, and then for example you might have this file connection which allows you to connect to the device file system and stuff like that. So you might want, and then now you might also have other options that if someone doesn't support, if a phone doesn't support file connection, then let me use a different mechanism. But then due to the way that, if you specify file connection, you'd have to, it's somehow hard-coded in the build that you do, because you have to specify the package itself and the path, you have to specify it. And if you do that, if you try and install that in the phone, then it says the app is not, cannot be installed because this phone doesn't support. Yeah? So what you're stuck with is having to make different builds of the same app. And then maintaining that is also can be quite complicated and expensive. Another shortcoming of, for example, if you want to support an application across a varied number of phones, then, for example, you want to use the native UI controls. So that's my next point about what you have is, for those of you who have done midlets, when you put in some of the controls and you construct the UI interface, it looks quite a bit old-fashioned, but you're more or less guaranteed it works across most phones, right?